So hello everyone. So today we'll be doing some questions on log. So let's get right into it. And there are some of the properties of the log which we have done in our previous video. If you haven't checked that out, please go check that out. So let's solve the first question, which is if a is equals to log 2 base 10, then what is the value of log 5 base 10? Why don't you just pause the video and try to solve the question? So now we have to find log 5 base 10, and we have given a is equals to log 2 base 10. So somehow we have to convert this 5 into 2. So what can I do is I'm going to replace this 5 by 10 divided by 2. Fair enough. So and I'm going to use the property above. This is going to return me log 10 base 10 minus log of 2 base 10, and this is 1 and this is a. So therefore that's my answer. This is the first problem. Let's move on to the second one. So if a is equals to log 3 base 30 and b is equals to log 5 base 30, then find log of 8 base 30. So in this, what I'm going to do is I will first solve log 8 base 30. I can write 8 as 2 cube. So this 3 is going to come down here. So 3 times of log 2 base 30, and then I'm going to replace this 2 by 30 upon 5 into 3, and then 3 times of log 30 base 30 minus log 3 base 30 minus log 5 base 30. So this is going to return me 3 into 1 minus a minus b. So that's the answer for the second question. So now let's move on to third question, which is log of 2 of log of 4 is x is equals to 5. So find x. So in this one, what I'm going to do is I'm going to take anti-log both the sides. So the log 2 from the LHS will be removed. So taking anti-log both the sides with base is equals to 2. So if I'm going to take anti-log, so my log 2 will be removed and this will be 2 raised to the power 5, and I'm going to do this step again, but the base is going to be 3. So log 3 will be removed from the LHS and 3 raised to the power 2 raised to the power 5, and again the same thing with base is equals to 4. So my x is equals to 4 raised to power 3 raised to power 2 raised to power 5. So that's my solution for x. So for the next question, 2 raised to power 3 raised to power x is equals to 5. Then find x. So in this one, we are going to do log both the sides because the x is in exponential form. So we want it down. So what I'm going to do is taking log both the sides, and here my base is 2. Okay. So this will be 3 raised to power x is equals to log 5 base 2. And again the same thing, I'm going to take log with base 3. So this is going to be my x is equals to log of log 5 base 2 base 3. So that's my answer for the fourth question. So let's move on to the fifth question. The fifth question is, if a is equals to log 2 base 3, then write log of 12 base 36 in the form of variable a. So in this question, so my log 12 base 36, so what I'm going to do is I'm going to write 12 as 2 cube into 3, and 36 is 2 square into 3 square, and I can write it as log of 2 raised to power 2 square into 3 upon log of 2 square into 3 square, and I can write this as log 2 square plus log 3 plus log 3 upon log 2 square plus log of 3 square. Now this exponent is going to come here, so it is going to be 2 log 2 plus log 3 upon two log 2 plus 2 log 3, and I'm going to divide the numerator and denominator by log of 3. So 2 log 2 by log 3 plus log 3 by log 3 upon 2 log 3 plus 2 into log 3 upon log 3. So this will be 2 times of log 2 base 3 plus 1, 2 times of log 2 base 3 plus 2, and this is my a. So I can write it as 2a plus 1 upon 2a plus 2. So that's the answer of the fifth question. So now let's move on to question number 6. So those are the easy ones. So now the medium level questions. So question number 6. Log x upon b plus c is equals to log y upon a plus c is equals to log z upon a plus b. Okay, then find x raised to the power b minus c, y raised to the power c minus a, z raised to the power a minus b. So what I'm going to do is I'm going to equate it as k. So my log x is equals to k times of b plus c. So log of x is equals to k times of b plus c. Same with the y and z. Log y is equals to k times of a plus c. Log z is equals to k times of a plus b. I'm going to write these as, I'm going to take the anti-log. So x is equals to e raised to the power k times of b plus c. If there isn't mentioned anything about the base, so you have to consider it as the natural log. So y is equals to e raised to the power k times of a plus c. Z is equals to the power, z equals to e raised to the power k times of a plus b. So I got x, y and z. So basically I have to multiply it by these terms. So what I'm going to get is, I'm going to calling it as phi. So my phi is equals to e is to the power k of p plus c, p minus c, plus, so these are dot dot dot, these are in multiplication, so the power is going to add. So k times of e plus c times c minus a, and then plus k e plus c and a minus b. Okay, so e, so I'm going to take k as common, and a plus b into a minus b is equals to a square minus b square. So I'm going to do b square minus c square plus a square minus c square. Sorry. It's going to be my, it's going to be my c square minus a square, c minus b, plus a square minus b square. So minus b with this plus a square a square. So this is going to return me to k raised to the power 0. It's going to return me e raised to the power 0, which is equals to 1. So that's my answer for the question number 6. Now let's move on to question number 7. So this one is very similar. Log x to the previous one, log x upon b minus c is to log y upon c minus a equals to log z upon a minus b is equals to k. Okay, then find x raised to the power a, b raised to the power, x raised to the power a, y raised to the power b, z raised to the power c. So similar to the previous question what I just did here, so the same thing will be done here. So I'm going to skip this step, and I'm going to write like this. So my x will be x is equals to e raised to power k raised to power b minus c. My y is equals to e raised to power k raised to power c minus a, and my z is equal to e raised to power k into a minus b. So x raised to power a, y raised to power b, z raised to power c, which is equals to e times of k into ab minus ac dot, that means plus multiplication, so the exponent have to be added. So k times bc minus ba plus k times of ca minus cb. So now take common, plus bc minus ba plus ca minus cb. So let's see, this is going to cancel with this, ca c and bc. So e is power 0. The answer is again 1. So this question was also medium level. So the next question, my question number 8, this is going to be ln of x minus a plus ln of x is equals to 1. Then find x. So basically ln is a special log in which the base is equal to e. So if you write like this, log e or ln, they means the same. So this question, what I'm going to do, use the property ln of a plus ln of b, which is equals to ln of a b. So ln of a into b, so x into x minus a is to 1. So now I'm going to take the anti-log. So x into x minus a is equals to e. So this is my quadratic equation, x square minus ax minus e equals 0. So x is equals to minus b plus minus under root of b square minus 4ac upon 2a. So this is going to be my a plus minus under root of e square plus 4e divided by 2. So I can write it as a by 2 plus minus under root of e square by 4 plus e. So this is my answer for the 8th one. But hang on, the negative part has to be neglected, because when you are going to put the negative solution in the equation, it is not going to satisfy, the ln is not going to satisfy. So this x has to be greater than 0. but it won't be greater than 0. As you guys can see, x, this is not greater than 0, so we have to neglect the negative part. So this is not our answer. So our final answer will be x is equals to a by 2 plus under root of e square by 4 plus e. So this is my final answer. Okay, so now let's move on to question number 9. Okay, so find log of 4 base 3 into log of 5 base 4 into log of 6 base 5 into log of 7 base 6 into log of 8 base 9 into log of 9 base 8. Sorry, this is going to be 7. So I have to solve. So if I write log of a base b, I can write it as log a upon log b. So using this property, log 4 upon log 3 into log 5 upon log 4 into log 6 upon log 5 into log 7 upon log 6 into log 8 upon log 7 into log 9 upon log of 8. So log 4, log 4, log 5, log 5, log 6, log 6, log 7, log 7, log 8, log 8. So log of 9 upon log of 3. So I can write it as log 9 3, and I can write the 9 as 3 square 3. This 2 will come down here, so 2 times of log 3 base 3. So the answer is going to be my 2. Okay guys, so our last final 2 questions, the last second one, question number 10th. So these two are good level questions. So 3 raised to the power x is equal to 4 raised to the power x raised to the power x minus 1. Then find slash solve for x. So as in both sides x is in the exponent, so we want that x down here, so we have to take the log both the sides. So taking log both the sides, it is going to LHS is going to be x times of log 3 is equals to x minus 1 times of log 4. So now x into log 3 is equals to, I can write this log 4 as log 2 square this, and this square will come down here, 2 times of log 2. Oh, sorry about that. So I'm going to replace this by this, so 2 times of x minus 1 into log 2. So now this is going to be 2x into log 2 minus 2 log 2 x log of 3. So like terms on the right hand side, so 2 times of log 2 minus log 3 into x, and this term on the LHS side, so 2 log 2. So my x is 2 log 2 upon 2 log 2 minus log of 3. So that's my answer. So what can I do is I can even more simplify this by dividing it by log 3. Log dividing it by 2 log 3. So 2 log 2 upon 2 log 3. 2 is going to cancel with this. 2 log 2 upon 2 log 3 log 3 2 log 3. This is going to cancel with this. This will be cancel with this. So my final answer is going to be 2 log 2 base 3 upon 2 log 2 base 3 minus 1. So that's my answer for the 10th question. So now this one is the most difficult question of all of them, amongst all of them. So question number 11. So start. It's an important one. So let's see if you guys can solve this one. So just solve. So log 9 base 2 square and in their power 1 upon log 2 log 9 base 2 into root 7 1 upon log 7 base 4. So this question is very good one. So let's see. It looks a little scary, but trust me, this is the very simple questions. So firstly we are going to solve this part. So 1 upon log 7 base 4, I can write this as log of 4 base 7. These are going to interchange. Okay, so I can replace this by this here. So root 7 raised to the power log 7 is 4, and the 7 is root, the square root, so I can write this as 1/2. 7 raised to the power half of log of 7 is 4. So this half I'm going to pass to this 4. So what is going to return? 7 log 7 and the square root of 4. 4 raised to the power half. That's the square root of 4, which is 2. So 2, and this with this I will be getting 2. So this part is returning me 2. And let's look to this part. So it looks really messy. So but what we can do is, as you all guys can see, log 9 base 2, you can see this part down here and here. So what I'm going to do is, I'm going to do log 9 base 2 is equals to t. I'm substituting this log to t. So what I'm going to get is t square 1 upon log t base 2. It looks now really simple. So let's solve it further. T square, I can write this 1 upon log t base 2 as log 2 base t, and this 2 is in multiplication with this, so I can write it as 2 log 2 base t, and this 2 can go up here to this power. So this going to return me log t log 4 base t, and again this will going to return me 1, and there the answer, there are the 4 remaining 4. So this part returns me 4 and this part returns me 2, and we have to just multiply them. So our answer is 8. Was it then simple? So till now we have covered very basic logs, which we will be further doing in integration, differentiation in calculus, but the higher level of log we will be covering it later. In the next video we will be covering differentiation. So thank you all for watching. Please do like, subscribe and share.